In today's video, we're going to talk about reactions that take place basically in water. A lot of times we refer to those reactions as reactions that occur in aqueous solutions, okay? But really it's taking something and putting it into water. And water is just a convenient medium because it's cheap, it's readily available. Obviously it falls from the sky. So when we talk about aqueous solutions or aqueous reactions, we're just talking about reactions that are happening in water. Now, what happens though when you put some things into water is we already talked about this when we talked about the properties of metallic, covalent, and ionic compounds. You put a covalent compound into water like CO2, it doesn't do anything. It will dissolve to a certain extent, but it's not going to necessarily do anything, okay? It's ionic compounds that really are the ones that are going to do something, okay? When you take sodium chloride, NaCl, and you put it, and it's a solid, and you put it into water, it doesn't just like sugar, you put sugar into water, and the sugar breaks into just smaller pieces of sugar. But it's still, the formula for sugar, C12H22O11, that's a covalent compound. It's still just molecules of sugar, okay? They just break into smaller pieces. Instead of grains of sugar, they turn into much smaller pieces of sugar that we can't see. Okay, an ionic compound, that is the term that we're going to use, is called soluble. What happens when you have a soluble ionic compound is they actually break apart into ions, okay? Which means you have sodium ions, that's AQ, and you have chloride ions. So when you have a glass of salt water, what you really have is a glass of water with a bunch of sodium ions in it and a bunch of chloride ions in it. Okay, not sodium metal and chlorine gas, sodium ion and the chloride ion, which are much more stable. Okay, in the ocean, what do you have in the ocean? You have a whole bunch of sodium ions and a whole bunch of chloride ions. Some might say, well, no, you don't, because when you boil off all the water, there's just a bunch of salt left on the bottom. Yeah, because as the water goes away, the ions come back together and reform as the ionic compound NaCl. Okay, but when it's in the water, remember we talked about in Unit 2, we talked about ion dipole forces. Okay, there's our ion, and they form those attractions. Remember the water, the oxygen is turned towards the sodium, and with chloride, because it's negative, the hydrogens are turned towards the chloride ions. Okay, those really strong ion dipole forces are able to pull those those ions apart from each other to create these ions that are floating around in the water. Okay, so, and when that happens, when you have ions floating around in the water, that's what allows water to conduct electricity. Okay, water by itself does not conduct electricity. It's the ions in the water that allow the electricity to flow. Okay, so when a large number of ions are present in the solution, you have an excellent conductor of electricity. Okay, and what we call that, when something conducts electricity, we call it a strong electrolyte. Okay, just like those Gatorade commercials where they talk about replenishing your electrolytes. Okay, Na plus and Cl minus are electrolytes. Okay, potassium is another one they use in Gatorade because it's again, K plus is an electrolyte. And so when you talk about replacing them, all that an electrolyte is something that conducts electricity. They make it sound fancy in the commercial. Oh, well, I'm going to go buy some Gatorade. I need to replenish my electrolytes. Okay, now with ionic compounds, that is the case. And notice here it says all soluble ionic compounds and all strong acids, we'll talk about that in just a second, are strong electrolytes, okay? What that means is it means that all ionic compounds are not soluble, okay? Some ionic compounds, obviously, think about like calcium carbonate. Calcium carbonate is the chemical name for limestone, okay? Limestone or marble. Of course, every time you put, marble is like, like a building is made with these beautiful marble statues and things like that. Of course, every time it rained, if calcium carbonate were soluble, it would slowly dissolve over time. Okay? Calcium carbonate is not soluble. It's an ionic compound, but it is not soluble. Okay, so some ionic compounds are soluble, some are not. Okay, how do you know? Well, there's a big, long list, but again, for the AP test, I said, you know what, forget about the big, long list. Let's just focus on a few of these. So, the soluble ionic compounds that you need to know, which means you need to have in your brain, are compounds that contain an alkali metal. What's an alkali metal? Lithium, sodium, potassium, rubidium, cesium. The ones in that very first column, obviously other than hydrogen. Okay, so lithium down are the alkali metals. Anything that has an alkali metal in it, so lithium, sodium, potassium, rubidium, cesium, and technically francium, I guess, as well. Okay, those are your alkali metals. Anything with one of those in it is 100% of the time is going to, just like here, break apart when you put it into water. Okay? So, and again, the fancy word is, it means it completely dissociates when added to water. It breaks apart into ions. So any compound that has an alkali metal in it, okay, is going to be soluble. Okay, and then the next one is the ammonium ion. Anything that has an ammonium ion in it. Ammonium is NH4 plus. Okay, if it has NH4 in it, not NH3, NH4, if it has NH4 in it, it's soluble. And then the last one is nitrate. Okay, and hopefully you remember that nitrate is NO3 minus. Okay, those are the ones that are always 100% soluble. So if you have, for example, MgNO32, and you put that into water, if you put some magnesium nitrate into water, what it does is it breaks apart into ions. So magnesium has a +2 charge, so you're going to have Mg2 plus, and then notice you've got two nitrates here, so you're going to put two NO3 minuses. Okay, and there's a couple more examples I'm going to show you down below. Okay, and that's what happens. Any of these here, any of those here, if it's any of those, they always break apart into ions. Okay, and then there also are 7, again, remember it said the soluble ionic compounds. Now we know which ones they are. Alkali metals, ammonium, and nitrate. Okay, and then also the strong acids, and there are 7 of those, okay, and they're right here. So those are the 7. Anytime you put them into water, they completely dissociate. Okay, if it's any other acid, and they don't tell you whether it's strong or weak, then it is weak, unless it's one of these, again, one of these 7. So hydrochloric, hydrobromic, hydroiodic. I kind of put them into 3 groups. It kind of helps me remember them better. So I kind of have those 3 together in a group. Hydrochloric, hydrobromic, hydroiodic. And then chloric and perchloric are these 2. Okay, HClO4 is perchloric acid, where this is just chloric acid. And then again, here's nitrate. Remember, just like before when we talked about nitrate? So then I kind of group these last 2, nitric and sulfuric acid, together. So I've got the 3 that are halogens, HCl, HBr, and HI. That's 3 of them. And then the 2 with the chlorine in it, HClO3, HClO4. And then the last group, I just kind of clumped the last 2 together, nitric acid and sulfuric acid. Okay, those are all 7 of them are strong acids, and when you put them in water, it means that they completely dissociate. Okay, and again, what does that mean? It means you take HCl and you put it into water, and what does it do? It becomes H plus and Cl minus. And again, you've got these aqueous ions that are floating around in the water, just like how we drew right here. Okay, and it happens with all 7 of those acids. Any other acid, it doesn't do that with. Okay, so here's an example of ammonium chloride. Again, you've got your ammonium, the positive ion, and the negative ion. So you get NH4 plus, and you get Cl minus. Anytime you put that in water, okay, that's what that ionic compound will break into. Okay, and remember the negative ends of the water molecules, which is the oxygen. So again, if you're going to draw that, you're going to put oxygen here, put the oxygen, and then the H's outside. And then on chlorine, you put the hydrogens closer to the chlorine, and you put the oxygen away from the chlorine. Okay, when those ions are surrounded by water, we say that they are hydrated, which means they have the maximum amount of water molecules that can be around them. Again, that attraction between the water and those charged particles are called ion dipole forces. Okay, the Cl minus and the NH4 plus are the ions. The water is the polar molecule, and that creates those really strong forces. Okay, example 2, sodium chloride. That is, it's got an alkali metal in it, therefore it breaks apart when you put it into water, so you get Na plus and Cl minus, just like how we talked about earlier. Okay, hydrobromic acid is a strong acid, so when you put it into water, it does completely dissociate into H plus and Br minus. Okay, and so really, just to kind of summarize here, if you have a solution of NH4Cl, NaH, NaF, Na anything, or a solution of HBr, HCl, H2SO4, HNO3, etc., or any other soluble ionic compound or strong acid, you don't have this. You have this dissolved. You have that ionized form of each of those compounds floating around in the water. Okay, and that is your introduction there to strong electrolytes. In our next video, we'll talk about weak and non-electrolytes.